Please help me welcome theoretical physicist, author, and adventurer, Dr. Adriana Marais.
I want to go to Mars because, to me, the allure of the unknown has always felt far more powerful than the comfort of the known. Thank you for your attention.
Proudly Human's Off-World project is a series of habitation experiments in the most extreme environments on the planet to prepare for life on the Moon, Mars and beyond, and to improve standards of living on Earth. During each experiment of several months, a carefully selected team will arrive in an isolated location, build infrastructure from scratch, run projects, and live as a community while participating in making a documentary series. Do you have the right stuff? We are looking for resilient people with diverse expertise, a passion for adventure, and a story to tell. Apply now to join our off-world community.
When we allow ourselves to dream, when we believe in our dreams, and more importantly, when we take active steps towards achieving those dreams, that it becomes possible to create a proudly human future, whatever planet we're on. Thank you very much.
Fun. Good morning, everyone. I'm so excited to be here with you all this morning. So good morning to our esteemed current leaders, and good morning to our future leaders. Good morning to our current experts and our future experts. That video was actually a call for applications for our off-world project. That's for real. Our applications are still open. So while I'm busy talking to you about a bunch of things I'm extremely passionate about, and my only challenge today is to fit it into the time, so bear with me. While I'm sharing a few things that I'm passionate about, I want you to personally think about your project application. Would you be volunteering perhaps to go on our desert expedition? Would you be volunteering to go on our expedition to Antarctica? Would you be volunteering to go on our expedition under the ocean? Or perhaps you'd like to skip all that and volunteer to go to the Moon or Mars. I want, during the talk, for you to think very carefully, what would your project proposal look like? And we're going to return to this question at the end. So before we start, for those maths lovers, you'll be happy. For the rest of you, there's an app that I'm going to ask you to download, because we're actually going to do a quiz at the end of the talk, and we're going to put the highest and the lowest scorers up for everybody to see, so please focus. I'm joking. You can relax. It's my challenge to fit my story into this time with you today. This is indeed a page out of my thesis. So I am a quantum physicist by training, and if you'd like to discuss equation 1.26, we can do so afterwards. But for today, let's talk a bit about space, right? And I'm hopefully going to draw a link between quantum physics, my training, and space in the next few slides. But what is the purpose about exploring space? First of all, I think it gets people excited. But importantly, it also helps us to answer the big questions. So what are the big questions? Okay, forgive my joke here that the alcohol molecule looks, if you have an imagination, a bit like the rhino. But importantly, we have not yet answered the question, what is life, from a scientific perspective? Big question for people enthusiastic about doing science out there. We have not yet understood exactly the difference between a collection of molecules and the amazing collection of molecules that makes up you, me, and all living things. And this is a question that I was interested in my research, trying to understand life from the perspective of the molecules that make up living systems. And what we realize is that life on Earth is actually one big family. So studying life on Earth doesn't necessarily help us answer the big questions like, is there life out there? Where did life on Earth come from? And what is the future of life on Earth? And if I could say it quickly, the reason why life on Earth is one big family is that in every single living system that we look into with our microscopes, we find the same molecule, DNA. We are all related through this double helical structure, a few nanometers wide, that we share with all other living systems, from microbes through to mammals. All of us have this DNA molecule in common, which makes us one big happy family. We can even see life from space. And so the question we're asking is if we need another data point right? Because we know if we're collecting data, we need more than one data point to try to understand something. We like to have data sets. And if we need data sets, that means we're going to have to search for life beyond Earth to compare it to Earth, and maybe then we can answer the question, what is life? Is the answer in the stars? So back in 2009, we were extremely excited in South Africa and Africa to know that the mere precursor for the Square Kilometre Array radio telescope began construction in the Northern Cape. So by the time I was studying quantum astrobiology in 2015, Meerkat was nearly complete and nearly operational. And we were super excited that in the future, when the SKA is fully functional, we will be able to look for the building blocks of life in space with 50 times more resolution than ever was possible before, because the SKA radio telescope will be the most powerful telescope we've ever developed, able to look into the galaxy and into the universe with a higher resolution than ever before. So in 2016, I was super excited to travel to Mexico to present my work on astrobiology at the International Astronautical Congress, looking at exactly this question, how looking into space for molecules can tell us about the origins of life. So also at this conference in Mexico was somebody you've probably heard of, South African-born Elon Musk. And there's a selfie with me and Elon, so I don't think he knew he was in that photo, but that was him. That was me and Elon in a selfie in 2016 in Guadalajara, Mexico. And excitingly, at this conference, Elon presented SpaceX's plans to build the Starship for the first time, which can take 100 tons of cargo or 100 people at a time to the planet Mars. Elon announced that this, in fact, had been his plan the whole time. Collecting resources, collecting revenue, building teams to take the first humans from Earth to the planet Mars. Okay, this was super exciting, to be in that audience of like thousands of people drinking coffee. It felt like you're in a stadium going to watch a soccer game, but in fact this was a space talk. There was nearly a stampede to get in, but I think the world held their breath when Elon announced humanity is going to Mars. So, while I'm waiting for the SKA radio telescope to be complete, maybe I can get to Mars first, was my thinking. And Mars can help us answer the big questions because, if I have to be brief, we know that Mars once had liquid water on the surface. We see pebbles, we see canyons, we see coastlines, we see things that water created. Now, another thing about life on Earth, it has DNA, but another thing is that all life on Earth needs water. So, if Mars once had water, did Mars once have life? And if we can use Mars to answer that question of whether there was life on Mars, this is going to be a big step forward in understanding what life is. So luckily, back in 2012, I had already applied for the Mars One project. And in 2015, 100 candidates were selected from around the world to travel to Mars on a one-way trip because they were budget constraints for the trip back. There were 4 South Africans amongst the 100. There's me in the top, 1 Nigerian, 1 Egyptian, so 6 Africans would have been part of the mission to Mars. It could have been next year. Okay, hold that thought. We'll get back to the Mars One project. But let's just talk about what else has been going on Mars, because Mars might feel far away, and it is 200 million kilometers away. Even light takes 10 minutes to get there. But in fact, even during the pandemic, we had traffic to Mars, if I can call 3 craft traveling from Earth to Mars traffic. So we had the United Arab Emirates' first attempt to get to Mars successful. They didn't land on the surface, but they put an orbital mission called the HOPE mission. And it's indeed hopeful that we're having new regions enter into the space game. And congratulations to the UAE for getting their HOPE mission into orbit around Mars, where it is now collecting data and doing research on the atmosphere on Mars. This was during the pandemic, successfully arriving in 2021 after a 7-month journey. That's how long it takes to get there at the moment. We saw NASA launching their 5th rover to Mars, the Perseverance rover, which had the Ingenuity helicopter like a drone on board, getting to Mars again during the pandemic, launched in 2020, arrived 7 months later to the surface of Mars. And if you've seen this amazing high-resolution footage of the surface of Mars, This is because the cameras that are on board, the Curiosity, the Perseverance, the Chinese rover, have really high resolution cameras and the capability to send back data so that we can see the surface of Mars like never before. Then we have China, and we have to say a huge congratulations to China in the first attempt, getting to Mars, putting an orbiter in orbit, but also deploying a rover on the surface, which was successful. It's currently moving around on the surface of Mars, and all of this was the first time China had ever attempted to get to Mars. So really a huge congratulations to China, and thanks to that, we now have 3 rovers on the surface of Mars, the Curiosity rover, the Perseverance rover, and the Tianwen-1. So that's what we've been doing on Mars, and you might say, you know, what's the point? Why all this activity to Mars? And you might be surprised to know that the main objective of these missions is to look for life. So this question, what is life and does it exist on other planets, is not just my crazy question. It's a question we're spending a lot of money on trying to answer. And not because we're trying to make money, but because we're actually trying to generate knowledge. So money is spent on space exploration to do many things, but also to generate knowledge and answers to those big questions that humans have always had. So let's go back to the people, right? The technology is happily roving on Mars, sending us back footage. But what about people? Well, China announced that they will send crew to Mars in 2033, 10 years' time. Think about how old you are now and how old you will be in 10 years' time. And whether you might be one of the Chinese crew. Who knows? You could move to China and become a Chinese astronaut, a taikonaut. But China has announced this date, so let's see. What about SpaceX? Elon announced in 2016 they're building the Starship to get to Mars. The date has changed a bit, but currently 2029 is the date. So where will we be when that happens? I'm sure we'll all be watching if it does take place. And maybe, just maybe, some of us will be among the people arriving there. So I'm going to get back to these topics with some more updates, but first let's talk about a place closer to home, because in the next 10 years there's going to be a lot of activity there too. The moon can also help us to answer questions. We don't necessarily think there may have been life on the moon because there isn't evidence of oceans like on Mars, but the moon can help us understand power production, understand water management, understand growing food in space, and many of the other questions that we need arguably for Earth, as well as space exploration. So a little recap on what's happened on the moon. We know people were there for the last time in 1972. Some of us weren't alive in 1972, so that feels like a very long time ago. But excitingly, in the next decade, we're going to see more human activity on the surface of the moon. We've got 7 rovers there in total. Congratulations to Russia, who on the weekend sent a lander to the moon for the first time in more than 40 years. And the 7 other rovers, including this one from China. So NASA plans to send people back to the moon in 2025. I suspect that date might change, but probably in the 2020s. And that might look familiar because SpaceX is building the lander. So before SpaceX sends humans to Mars, they're going to test the lander, a critical point of getting somewhere, landing there safely, on the moon in collaboration with their partner, NASA. We've got China and Russia collaborating on an international lunar station for 2028. So interestingly, the NASA base is planned to be powered through solar and through hydrogen, which can be created from water, which will be extracted locally on the moon through electrolysis, which breaks the hydrogen from the oxygen. And in fact, we've been doing that in space since the 1960s. And the Chinese-Russian base is planned to be nuclear-powered. So this will be a very interesting perspective from the perspective of power generation of how these 2 bases will perform and how we can generate power redundancy using a different array of systems, whether that's hydrogen fuel cells, or a nuclear approach that China and Russia plans. So there are a lot of regions getting involved in space exploration, even regions that hadn't been involved before. So the question is, how will we take part? This was certainly my question and maybe your question too. So let's come back down to Earth a bit. Maybe that's all very exciting, especially for you guys, because at this age you are perfectly poised to participate in the return to the moon and our journey to Mars, because you are at the perfect age, right? These missions are all happening in the next 10 years. You've got time to choose your subjects, choose your university courses, to really contribute to our expansion beyond Earth. So super exciting. Congratulations. You've arrived at the right moment in history on Earth to be part of all of that. But let's come down to Earth a bit, because I've got some not so great news. The Mars One project declared bankruptcy in 2019. So I show this picture because I think the successes of the Mars One project were collecting the 99 other besides me extraordinary humans that we still keep in touch with. Also, the Mars One project got a mention on South Park. So Cartman actually volunteered for the Mars One project in an episode on South Park. Sheldon Cooper volunteered to go to Mars with the Mars One project in an episode of The Big Bang Theory. Lisa Simpson volunteered to go to Mars with the Mars One project in an episode of The Simpsons. So I was actually happy that my 3 favorite TV shows all mentioned the project that I was a part of, even though it's a startup and it didn't raise the money that they expected. So that's the outcome there. Fine, Mars. Okay, let's come closer. What about the moon? And we are really excited in South Africa to be building infrastructure at Fontein in the Karoo to relay signals to support the crew going back to the moon with the Artemis program. However, are we going to be observers to this return to the moon, or are we going to be participants? Can we do more than just relaying signals for the return of crew to the moon? My clicker doesn't seem to work. Oh, there we go. So let's recap on Africans who have been to space. And currently we only have one astronaut, Mark Shuttleworth, who earned enough money to pay for himself to go to space in 2002. And while we are proud of him, and that's a great achievement, is this where we're going to leave it? Are only people who can afford to take themselves to space going to represent our continent in the drive to expand beyond Earth? Are space enthusiasts like Ruvimbo Samanga, who is a space policy expert from Zimbabwe, and myself going to have super exciting Zoom calls with people in space? Okay, this was cool because Etienne Steeb was in fact in space during this call, and the signal was excellent, better than some of the Zoom calls I've had in wherever in the world, to be honest. He was literally floating in space during this Zoom call, having a call with us back on Earth. But are we going to stay in the audience? Are we going to stay as observers to this, participating in remote support and Zoom calls with the people who are doing the adventuring? And I say, as you can imagine, no. And so let me share now some of the projects that I'm involved in that really wants to put Africa in a participatory role in this exciting era of space exploration. And these are just a few of the projects that I'm working on. And hopefully some of you can join some of these projects, or even more importantly, start projects of your own, because it's the perfect time to be creating initiatives to take part. So before I talk about what, let's talk about why. Why should Africa get involved in this drive to expand human knowledge and human presence beyond Earth? And let's reflect on some of the technologies that have come out of space exploration. And then I think you will see that the kind of technologies developed for space are exactly the kind of technologies that we need for a more resilient and a more sustainable future here on Earth. The first solar-powered satellite was launched in 1958, just 1 year after the first satellite was launched. If we had not been developing solar-powered technology for space for the last 50 years or more, where would we be today in the drive to shift from fossil fuel to more renewable energies? The space sector has driven the high efficiency, low mass, high resilient technology and materials that create the solar panels that we are able to use today. What about the next thing? Power, we get to water. Well, in fact, the first hydrogen-powered rocket was launched in the 60s. The first electrolysis system in space split oxygen from water in the 60s. And indeed, the purification of water into perhaps hydrogen and oxygen to breathe, or just the use of water for the astronauts on board, the purification systems to cycle this water in the International Space Station have led to a lot of the systems that we use today to purify our water, whether that's in a community-based or a household-based or an industry-based setting. Came from initiatives in the space station because, as you can imagine, water is heavy. You can't take all of your water with you when you leave Earth, so you need to recycle your water. And guess what? That's something we need to do better at here on Earth also. When we think about growing food for increasingly urbanized populations, when we think about reducing the transport of food, when we think about reducing the amount of pesticides and resources to grow food, indoor farming has become a catchword, and smart farming and vertical farming, and hopefully more than words. Hopefully we will soon be producing food in the places where people live. And in fact, the first food was grown in space in the 80s. This is a plant, a flower that blossomed more recently, but the Soviets were growing plants in the space station since the 80s. So developments in LED lighting for growing plants without sunlight, for example, have been driven by the effort to produce agriculture in the multiple space stations that we've had since the 1980s. So we've talked about power, we've talked about water, we've talked about food, and now let's talk about communication systems, because for me these are the fundamental resources for a human community, whether we're living on Earth, whether we're living on the Moon or Mars or beyond. And here's an example. India also got to Mars successfully in the first attempt back in 2017. Huge congratulations to India, an orbital mission called the MOM mission. And to justify the expenditure on that Mars orbital mission, they utilized the satellites that were put in orbit around Earth to distribute telemedicine and remote education to all parts of India as a result of the satellite array that was sent up. So whenever you invest in space, there are always repercussions, positive repercussions in innovation, in social improvements back here on Earth. Those are just some examples. So that's a bit about the why. Space is not far away, after all. We are already in space, and I'll get back to that point in a moment. And in fact, arguably, we are in one of the most extreme places in space right now, planet Earth. Mars is quite predictable. Mars, not much changes, like literally in the last 2 billion years. Not a lot on Mars has changed. On Earth, by comparison, things are extremely unpredictable, and that's because our society has grown to a point where we are impacting the planet. So my argument is that we are in the most extreme part of space already. And so all of the lessons that we can learn from exploring beyond Earth can teach us valuable lessons about how to mitigate the challenges we face on Earth and be more resilient going forward. So the projects that I've mentioned, if you would like to explore in the desert or under the ocean or in the polar regions of the Earth, we still have applications open. If you are over 18 by the time we launch, you can apply for that project. We will be collecting data in preparation for the Moon, Mars, and beyond. Because the life support systems that we will need in the desert, where water management will be critical, in the polar regions, where power management will be critical, under the ocean, where air systems will be critical, are all components of a technology spectrum that we need to implement in refugee camps, informal settlements, overcrowded urban centers, camps on the Moon, camps on Mars. These remain the same: power, water, food, communication systems, and of course managing waste. So that is what the Off-World project will consist of. I won't go into more detail, but you can read more online. Then excitingly, let's come from Mars back to the Moon. As far as I'm aware, there are no plans from any organization in Africa to send technology to the Moon. Please prove me wrong. However, the Foundation for Space Development Africa, founded by my friend and colleague Carla Sharp, is planning to put the world's first telescope on the Moon. Africa's first mission to the Moon, but also the world's first telescope on the Moon. So watch this space. We would like young people in Africa, when they look up at the Moon at night, to feel a sense of belonging, to feel that we also have tech there, to feel that we have high-resolution cameras on the surface of the Moon, sending back footage to show that we can also participate in this really exciting era of space exploration. I'm going to skip this one, but this is a project we're doing with Earth observation data. So whether we're doing satellites, whether we're doing the Moon, whether we're doing Mars, there are always positive impacts for people on the surface of Earth from space technology. So I think I've gone a few minutes over my time. I'll wrap up now. Let me remind you again, we are already in space. The sun is shining, the sun is in space, and so are we indeed. And let's go back to the project proposals. Maybe you want to be the medic for one of these expeditions. Maybe you want to be the engineer for one of these expeditions. Maybe the artist or the musician to give us meaning and beauty in our lives on these expeditions. But what I'd like to remind you is you don't have to apply for my project to implement your dream. You don't have to apply for anything I've told you about to implement your dream. You are already in space. You are a passenger on Spaceship Earth. And your team and your dream is something you need to bring into reality to create the kind of future that you want to look forward to. So I don't know if you've edited your face into Elon Musk's car so that you can imagine flying around the solar system. Maybe some of you are happy with your feet right here on home planet Earth, and that's great. I don't know what your dream is. I don't know what your project proposal looks like, but whatever planet you're on, probably on planet Earth for most of us, I hope that you achieve your dream. And through passion and curiosity and amazing events like this, we can share, we can collaborate, and get closer to creating a future that we can all be proud of, whatever planet we're on. Thank you very much.